All right, number 8. Number 8 also has a little bit of weird things happening with the graph here. So I would recommend either going to Desmos or using your graphing calculator to just check once you get to the point where you're plotting it on the graph here. I want to see everything else by hand, but once you get to actually graphing it, feel free to use your calculator. Okay, so first thing is, where do I start? I start with the horizontal asymptote because I can look at it in this form and I see that, okay, I've got the degrees here, so I see that I have a bigger on top than on the bottom. So bigger on top means there is none. So I'm going to go over here to the HA and I'm going to say, oh, there's none. Okay, well, that's interesting because that's going to change the way my graph looks. This is why this is another one that I would graph in your calculator, because if there's no horizontal asymptote, it's not going to look like our typical rational functions. Okay, so just keep that in your mind when you go to graph it. All right, at this point, the only thing I can figure out in this form are going to be intercepts and values from my XY table. But even then, it's going to be much easier to just try to do this in simplified form to see if anything cancels out. All right, so let's start first with breaking this down. So I'm going to factor out the numerator, which is going to be a GCF of x squared, and then I have x plus 3 left over. On the denominator, I don't have to slide anything, thank goodness. Save me some time here. I have x plus 3 and x minus 1. Okay, great. Now at this step, I'm going to pause. I know a lot of you are like, oh yes, I can cancel, awesome. But I need to make sure I note what x cannot be. X cannot be either of these things. This is a minus 1, so here, I'm handwriting. So x cannot be either of these. So I'm just going to come off to the side. I'm going to say x cannot be negative 3 and x cannot be positive 1 because that would give me an undefined denominator. So if it cannot be either of these, I have two options for that discontinuity. It's either going to be a vertical asymptote or a hole, like what we've talked about before. So how do I know? Well, something different happens here than happened in number 7. When I look, I can actually cancel these out. That means it's still undefined, but this action right here, let me not do it in that color because that is going to confuse me. Let me do a different color here. I'll use blue. So this action right here is what causes a hole to take place. So that actually means because this one canceled, this is going to be where my hole is. My hole is going to be at negative 3. All right, but holes are a little trickier than asymptotes because it doesn't mean there's a line. Like I know x is negative 3, right? But I don't know where to draw my hole. Is it up here? Is the y positive? Is it down here? So I actually need to find that coordinate for y. Okay, well, when x is negative 3, what is y? How could I find that? Well, I can just substitute it in. But like I said, I could plug it into the old equation, but let's just make our lives easier and let's go ahead and use that simplified equation. I'm going to use this equation here, and I'm going to plug in a negative 3. So for the whole, I'm going to say negative 3 squared over negative 3 minus 1, which is going to be 9 over negative 4. So 9 over negative 4. And I can go and plot that point, which is going to be somewhere over here. 1, 2, 3. It's a little more than 2, so I'm just going to kind of draw an open circle right here. That is my hole. It's kind of hard to tell. I'm going to label this as hole. I'm using a marker, so it's not great to see, but that is a hole. Kind of looks like a black hole, but you get the point. All right, so this is the hole in the graph. So it could have a full line going through this. I just need to see, make sure I note that this is an open circle here that the graph isn't going to cross through. All right, great. We found the hole. Now we also know that there's still one thing that x can't be. So if I look back over here, I know that x still can't be 1. Well, since it's not a hole, it's going to have to be my vertical asymptote. So at 1, I don't have a point. I actually know that x can't be anything at 1. There's no y value at all. So my calculator is going to say error when I get to that point. All right, so I have a hole and I have a vertical asymptote. I have no horizontal asymptote because we already found that. The only other thing I can do now, and once again, I don't really know a lot about the shape. If I knew that I had a horizontal asymptote, I could then sketch my graph from there, but I don't know a lot about the shape of this graph. So I'm going to have to plot some points, and I'm going to have to do a little bit of figuring out here. So I want to now find my x-intercept. So let me get my pen back. To plug x-intercept, you're going to plug in a 0 for y. So let's come up here. And for my x-intercept, I'm going to plug in 0 equals x squared over x minus 1. Okay, a couple of things to note. Note that we still have a quadratic and we have a rational, so it's going to be taking on a couple of characteristics here. So I already know that the denominator is going to cancel when I go to multiply by x minus 1. So I have x squared equals 0. Okay, so x equals 0, but this is interesting because x squared means it has a multiplicity of 2, which means it's going to bounce here. And that's because it's a quadratic, right? So like it could bounce at this point. So if x equals 0, it's actually going to be bouncing off of this point. So it's going to be approaching the asymptote and then it's going to bounce off and skip over that hole. So it's going to look something like this, which is kind of crazy. The other thing I want to figure out is, okay, I know it's going like this, so let's figure out what's happening when x is 2, what's happening up here. That'll kind of help me predict. I know it's going to be going something like this. So I'm going to figure out, okay, when x is 2, what is the value of y? So I will use the whiteboard over here. So when x is 2, so I'm going to change my examples from last time. I want to know what is y. This is just going to help me sketch it. And like I said, if you have your calculator, I would just fast forward at this point and just plug it in the calculator to find it. Okay, so when x is 2, let me use my equation. Y equals x squared minus 1. Y equals x squared minus 1. When x is 2, that's going to be 4 minus 1, which is 3. So I have a point at 2, 3. All right, so I'm going to come over here and I'm going to make a point at 2, 3. Okay, so 1, 2, 1, 2, 3. So I'm going to say that my graph is going to look something like this, okay? And if you're not sure that it looks like that, I mean, I know it does, but you can always pick another value over here to kind of sketch the shape there and see what that looks like. All right, and last thing is going to be to do the domain and the range for this one. So this one looks a little more familiar in the domain from what we've seen before. So it's all real numbers. It goes to the left, and then it hits a hole, and it hits this line here. So there's two things that it can't be. X cannot be -3 or 1, which is what we noticed up here. The range, though, once again, is similar to this one. It is negative infinity, right? But there's actually a gap right here. So I can't say all real numbers because it really jumps up here. So it actually goes from negative infinity, and then it's going to stop at 0. And it does touch at 0. There's no hole there. All right, and then it goes up, and it starts at 3. Is that the point that we found here? Yes, so then it starts back up at 3, and there's another bracket on 3, and then it's going to go all the way to infinity. And the only thing is y cannot be, make sure we put the value for this hole right here. So y cannot be 9/4, -9/4. And there's no HA, so that's the only thing that y cannot be for this example. Okay, so these are the last two that are really tricky. The bottom two down here are a little more straightforward. You should be able to sketch without needing a calculator, so jump to those if you just need a quick refresher.